time-critical type of code. You will not use C#, you will not use Java, you will use C, C++, okay? So that's why all operating systems internally are written in which language? Some is, of course, assembly language, but most of it is C and then some C++, okay? All video games are majority created in C, C++. Even if we use Java or C#, the core engine is always written in C or C++, okay? So once it comes to speed, nobody beats C, C++, okay? Why? Because we directly compile to machine code, okay? Now let's come to Java and C#. Both of them do not compile to machine code. Okay, so the question is why? What benefit we may have by not compiling to machine code. So let me quickly show you. Okay, see, when Java language was created, it had 3 goals in mind, okay? Make object-oriented programming easier than C++. Number 2, make it operating system independent so that we can run Java program on any operating system. Okay, and number 3, no memory leaks, so that the programmer does not have to worry about releasing memory from the heap area. So those were the goals of Java. Okay, so how did they accomplish this? Let me go one at a time. First, let me show you this part. How do we make a language operating system independent? Okay, one of the key things is, so key concept is not to compile to machine code. Because the minute we compile to machine code, we are stuck to that particular operating system, okay? So as we discussed, if we take a Java program, if we write a Java program, we pass it through the compiler. Do we compile it to machine code or some other code? Byte code, right? And byte code, as I mentioned again, it's not machine code. Okay, so how do we run it then if this is the CPU? Okay, in the memory of the computer, what do we load? JVM. And what's the one of the important parts of JVM? Bytecode interpreter. Right? So this will read the bytecode and tell the CPU what to do. Same way, read another line, tell the CPU what to do, right? Okay, so now how does it make it operating system independent? Okay, pretend this is, let's say, Windows operating system. Okay, now let's go to Mac OS. Okay, so again, so if this is the Mac OS as an example, okay, let's pretend somebody has developed the JVM for Mac. Okay, so this is the JVM for Mac, right? So of course we can load it over here, right? And what's the first important part of the JVM? Bytecode interpreter. So how will it run the same Java program? We don't even have to compile it again. See, we already compiled it one time. So this JVM will simply read this bytecode, tell the CPU what to do, read another line, tell the CPU what to do, without having to recompile it, right? So all we need is JVMs for different operating systems. And how many popular operating systems there are? Maybe 4 or 5 at most, right? Unix, some variations of Linux, Mac OS, Windows. So somebody can sit down and create one JVM for each operating system. So this way we just compile it once, we run it again. So once again, let me emphasize, if you wanted to create a new language tomorrow, okay, to compete with Java, Python, or whatever, and you wanted to make it operating system independent, what's the #1 rule you will need? As you compile it, you will compile it not to the machine code. Okay? You will create your own intermediate code, which you can interpret, right? What's the price we pay for this flexibility? Speed, right? So anytime we interpret, it becomes slow, right? Now, second and third parts, as I mentioned, second part over here was the garbage collector, right? So that as we keep using the heap, programmer does not have to worry about it. So that's why Java programs are very stable. You can run them for years. They won't overflow in our memory, right? And third part is the safety environment, so that if our program tries to access a protected area, which is only the operating system can use, it will immediately block us, right? Okay, so now Java was released in 1995. The .NET framework, of which C# is one of the languages, okay, was released in 2000. So for the most part, what they did in the .NET framework, they looked at Java, copied all the good ideas, and then introduced some new ideas. Okay? Because it came later, it can learn from Java. So once we write a C# program, again, our goal will be to also have operating system independence. So you can run C# on Mac, you can run it on Linux, you can run it on Windows. So anyway, how? As I mentioned, just JVM to run a Java program. What is the equivalent in the .NET world? So if this is the CPU, it's called CLR. Okay, so we will load CLR in the memory of the computer. CLR stands for Common Language Runtime. Just like JVM, it has 3 parts to it. What's the first part? Well, what's the second part? Second, third are the same. Garbage collector, safety. In my opinion, the runtime safety is a little better than Java in C# and .NET because it came later, so it can do a little better version control as compared to Java, as an example. Okay. Okay. Now the first part, remember our goal is operating system independence, so we cannot compile to machine code, because if we did that, then we'll be stuck to one operating system, right? Every time we wanted to run the program on a different operating system, we'll have to recompile it, okay? So the first part is not the same as Java, okay? The first part over here is just-in-time compiler, okay? What is a just-in-time compiler? Okay, so if we wrote a C# program, again, we'll compile it, but we will not compile to machine code. This is called IL code, short for intermediate language code, and not machine code. So that, just like JVM, we can create a CLR for different operating systems, and we can run the C# program on any operating system without having to recompile it, right? However, if we made it over here an IL interpreter, then C# will be same slow speed as Java, okay? So to make it faster, what this just-in-time compiler does it reads the IL code, and then it converts it to machine code. So then it will read some more IL code, convert it to machine code. So as it's running, it keeps converting it to the machine code. CPU only runs the machine code. So it directly goes to the machine code and runs it. The rest of the garbage collection safety environment are provided to this machine code as it runs it. Okay. So as you can see, the very first time we try to run a C# program, it will be slow. Why? Because not only it's reading the IL code, it's converting it to machine code. But one time we have run the program, it will cache this, meaning it will store it in the CLR. So it caches the machine code. So now if you try to run it again, it will directly execute the machine code, so it will run almost the speed of C, C++. So almost speed of C, C++. Hey, why do I say almost? How come it's not 100% same speed as C, C++?
It doesn't have to access the cache only.
If this is machine, I mean, I'm comparing the speed second time, not the first time.
Has to check the code.
Okay, C and C, C++, is there a garbage collector kicking in, checking the heap?
No.
No. Remember, anytime the garbage collector kicks in, CPU has to devote time to the garbage collector. Okay? So over here, there is a garbage collector. So roughly speaking, C# maybe 10 to 15% slower than C, C++. Okay? Again, the safety, that garbage collection requires the CPU to switch to another thread, and that's what slows us down, right? Okay, so to summarize the main concept is both C#, Java are very similar to each other, and that's why I was saying if you learn one of these languages, literally it takes you a day to learn the other language. Okay? They're not that different. Same thing, the other good news is if you know these two, to learn C++ is another day's job. Okay? So anyway, what are the similarities between the two? To run a Java program, we load JVM into the memory of the computer, which interprets the bytecode and tells the CPU what to do. Okay? Just as a minor point, Java also has a just-in-time compiler. Okay? Optionally, you can use the just-in-time compiler so that it will do the same thing like C# is doing, meaning it will convert to machine code and cache it. Okay? However, because Java emphasizes interoperability,